Okay, today I am going to explain about 8051 microcontroller. Okay, 8051 microcontroller unit 4. So what is microprocessor? First tell me, anyone. Microprocessor means what? Give response. Microprocessor means what? Tell anyone. Microprocessor means what? Hmm? Microprocessor means a CPU on IC. Okay, CPU on an IC means what? CPU consisting of an arithmetic logic unit and control unit. Okay, so CPU on IC is called as, in simple form, CPU on IC is called as microprocessor. If suppose we want to give the input to the processor, means we need to interface input devices, and output we want to see the output, means again output devices also we need to interface. And if you want to save the program, entire thing whatever we are sending to the CPU or processor, means again memory also we need to interface. So processor means what? A single CPU on IC. If suppose we want to do any application with the processor, we need to interface. But whereas microcontroller means all the devices. Okay, CPU means processor, program memory, input output devices, and clock generator, all are integrated on a single IC. Okay, processor means only CPU on IC, but whereas controller means all the devices, whatever the peripheral devices we are interfacing with the processor, everything will be integrated on a single IC. That is called as microcontroller. Okay, microcontroller means a what? A single chip. Okay, or CPU with all peripherals like RAM, ROM, IO devices, input output devices, timers, okay, ADC, etc. Okay, any external device, whatever you may be connect, everything will be inside, or everything will be fabricated on a single IC using embedded system, is called as microcontroller. Okay, microprocessor means a single CPU, whereas microcontroller means the everything, processor, input output devices, memory, clock, everything will be integrated on a single IC. Okay, single IC fabricated with embedded system, then that is called as what? Microcontroller. Okay, that is called as what? Microcontroller. So here CPU consisting of what? Arithmetic logic unit and control unit. Arithmetic logic unit, what is the purpose? As it name says, as it name says, hmm, what is arithmetic logic unit? As its name says, it performs arithmetical and logical operations. Next, second one is control unit. Control unit is responsible for timing of the communication process between the CPU and the peripherals. Okay, means control unit will generate some certain control signals. Okay, certain control signals for processing the any signal from peripherals to the CPU or CPU to the peripherals. Okay, that is about control unit. So microcontroller means the what? A CPU with all peripherals fabricated on a single IC, integrated on a single IC, is called as microcontroller. Okay, now see the differences between microprocessor and microcontroller. Microprocessor, it consists of ALU, control unit, okay, and registers and interrupt circuit, whereas microcontroller, it consists of ROM, RAM, IO devices, interfacing unit, and other peripheral devices. Okay, microprocessor supporting the data handling bits. Only few instructions are available, whereas the data handling supported by many instructions which are existed in the microcontroller. So here microprocessor will consisting multi-function pins, means one pin is used for the multi-functions. Okay, here more number of multifunction pins are present. Okay, here less number and here more. Almost all the numbers, all the pins are used for the multi-purpose in the microcontroller. Next, data and program addressing modes are same. Okay, data and program addressing modes are different. Means here one addressing mode is different for writing the program and as well as entering. Okay, storing the data or taking the data also same addressing mode we are using. Direct, with the help of the direct addressing mode, we can write the code for the program, and as well as to store the data also we can write the program by using addressing modes. But whereas here microcontroller, for data separate addressing modes and program also separate addressing modes. Addressing modes means what? The way of representation of the codes. Okay. Next, time delay in processor. The time delay is more to access memory and IO devices. Okay. Why? Because the memory and IO devices are connected externally to the processor. But whereas here all the devices, all the peripherals are connected inside, or it includes in it on a single IC. So the time delay is very less. No need to interface the any external device to the controller. So due to this reason, the time delay is very less. More hardware components are required, hence cost is high. Here, less hardware components are required, hence cost is low. Why? Because in the processor, everything will be interfaced. Okay, everything will be interfaced means the individually we need to purchase the input devices, we need to connect output devices, we need to connect. Okay, memory we need to connect. If suppose any external device we want to interface means PPI also we need to purchase. Like that, the hardware components more will be required in the processor. Whenever we want to take the any application with the processor, if same application will be taken with the help of the controller means no extra hardware, less hardware components will be required. Why? Everything will be included on a single IC. Here microcontroller means input output, memory, interrupts, timers, counters, everything will be fabricated on a single IC. But whereas in the processor, only CPU. Okay, processor means only CPU. Controller means CPU with the peripherals. So due to this, the hardware components required in the processor are very high. And whereas here in the controller, very less. So due to this, cost is low in microcontroller and here cost is high in the processor. And next, there is a flexible designing. Designing is typical and complex. Flexible designing means what? Processor means only one CPU. Okay, one CPU. Processor is what? One CPU. So only one CPU along with the clock generator and some register, temporary registers, we are integrating on a single IC. Means only three devices we are designing. But whereas here, same IC chip consisting processor means CPU, okay, some registers, input output devices, memory, and clock generator, interrupts, timers, counters, everything. So here the designing of the controller kit is complex and typical. Why? So many tools, so many devices are required. Okay. Next, processor. It is not easily synchronize the communication between the peripherals of different speeds. Okay. So here everything will be connected externally. Whatever application you want to take for that, everything will be connected separately. And the baud rate means the speed transfer of data from processor to the another device. Input is one device, output is another device, memory is also another device. Now between input output memory, the data will be transferred through the CPU in order to perform the any application. So the transfer speed may not be same for all the devices. For the input is the different, output is different, and memory is also different. So like that, here the synchronizing the communication between the peripherals of different speeds, whereas here everything will be connected inside. Okay, so it is easily synchronized. Okay, it is easily synchronized the communication between the peripherals of the different speeds. Okay, here not easy, here is easy. Understand, these are the applications of microprocessor and microcontroller. Microprocessor means CPU on a single IC. Microcontroller means CPU with all peripherals on a single IC. Is called as microcontroller. Both are fabricated with the embedded system only. VLSI technology. Okay. Next. So types of microcontrollers. Okay, types of microcontrollers. So these microcontrollers are mainly classified based on the number of bits. Bits means what? The data lines. Okay, bits means what? Data lines means how much data we can transfer at a time. Okay, so based on the bits, the microcontrollers are classified as three types: 8-bit microcontrollers, 16-bit microcontrollers, 32 microcontrollers, 32-bit microcontrollers. Next, memory devices. So here, based on the memory devices, again controllers are classified as two types: embedded memory devices, external memory devices. Means here embedded memory devices means the memory inside only we are integrating. Okay, controller means the what? All CPU with all peripherals on a single IC. Then that type of controllers are comes under embedded. If suppose memory we are using other than that internal memory, if external memory we are using, okay, extra additional external memory, for example, if suppose our CPU is filled, okay, no no memory is required, so no memory is empty, so we are using some pen drives or flash drives, flash cards, or hard disk we are using for storage of the memory. Okay, means externally we are using. So all, if suppose any controller is using any external memory, then those are comes under this external memory type controllers. Okay, second type is what? Based on the memory devices. Okay, based on the memory devices, again these are classified as two types. One is embedded systems and second one is external memory type. Next, based on the instruction set. Okay, based on the instruction set. Instructions means the what? The commands which we are giving to the controller. Okay, to do the certain function are called as what? Instructions. Okay, instruction set means a group of instructions are called as instruction set. So based on instruction set, these are classified as two types: RISC and CISC. CISC means complicated instruction set. Okay, complicated instruction set. RISC means reduced instruction set, means RISC will have the less than the instructions less than CISC instructions. Okay, if CISC is having some 5000 instructions, means RISC will manage the entire operations with 2000 instructions only. Okay, understand? Instruction set. Based on the instruction set, controllers are two types: RISC and CISC. CISC means complicated instruction set controllers. RISC means reduced instruction set controllers, means RISC will have the less instructions compared to the CISC. Okay, next, memory architecture. So here memory architecture, based on the memory architecture, again two types: Harvard architecture, Princeton or von Neumann architecture. Okay, Harvard architecture means the what? Here program. Okay, for memory we are using. Okay, so here in Harvard architecture, for storage of the program, separate memory we are using, and storage of the code, separate code or data, the separate memory we are using. Okay, for code separate memory, for data separate memory. Then that architecture is called as Harvard architecture. Princeton architecture means both in one. Okay, that may be a code or that may be a data. For example, move ax comma 28 means what? 28 we are moving into ax, so 28 will be moved into data segment, sorry, data memory, and move will be moved into the, move is a code, so that will be moved into the program code in Harvard. But whereas in Princeton, both will be saved in one memory only, means only one memory device we are using. Okay, see here, CPU program. So this is von Neumann or Princeton. Okay, for storage of data and program, only one memory we are using. But whereas here Harvard architecture, for program separate memory and for data separate memory, both are coming from the CPU. Okay, so based on these two architectures, again controllers are classified as two types. Understand? Von Neumann architecture means the what? Princeton or von Neumann architecture, for storage of program codes and data, same memory we are using, only one memory we are using. Harvard architecture means for program separate memory and for data also separate memory. Separate memory devices we are using for storage of program and data. So this is called as based on the architecture. Okay, so these are the main classifications. And again, based on the chip. Okay, if suppose IC chip we are using, then based on this some controllers will be classified. If we are using VLSI technique, then another controller. So based on the technique. Next, based on the family. Okay, if 8051 is belongs to the one family. Okay, Intel will develop the 8051. Next, Motorola means company, based on the company names who invent the controllers. PIC controllers are there, Hitachi controllers, Texas, ARM, and others. Okay, these are the based on the families. Okay, Intel again 8051. Intel developed 8051. Philips company also developed 8051. Atmel also developed. Siemens dollars. Okay, so these are the what? The types of the microcontroller. Okay, types of the microcontrollers are classified mainly as 6 types. One is based on the bits. Second one is based on the technique, means based on what material we are fabricating entire CPU and peripherals. And next, based on the memory devices, based on the company name, who invented, and based on the instruction set, and based on the memory architecture. Okay, this is about the main classification of microcontrollers. Understand microcontrollers. Next, this is the different features of the 8051 controllers. Okay, so first one 8031. Okay, before 8051 8031 is invented. In 8031 no rom. Okay, rom, no rom. And ram is about 128 bytes, not kilo mega. Okay, only bytes. One byte is equal to 8 bits. So totally 128 into 8, those many locations are available in this 8031 ram. Okay, two timers we are using, and 32 IO pins. Serial ports is one, means for communication with the external devices, the serial ports are used. So only one port we are using, and 6 interrupt sources. Okay, and 8051 ROM 4 kilobytes, means ROM gives the program memory. Okay, in order to store the programs or code, we are using ROM or ROM. So 8031 no ROM. Okay, 8051 4 kilobytes of ROM. RAM is 128 bytes. Again, same two timers, 32 pins, one serial port, 6 interrupt sources. 8052 ROM 8 kilobytes. Okay, 8 kilobytes double. 256 bytes. Here also double. Three timers, same 32 IO pins. Okay. Next, one serial port, 8 interrupt sources, and 8751 4 KB UV EPROM. Okay, so here EPROM means electrical programmable ROM. So nowadays ROM is replaced by electrical programmable ROM. Means here what is the difference between this ROM and this ROM is this is non-volatile. This is volatile. Means here we cannot erase the data, but whereas here we can erase. Okay, we can erase the data. EPROM means electrically programmable. Okay, based on the program, this data, whatever the data will be stored permanently, that can be erased. E means. Next, RAM means 128, two timers, 32 IO pins, one serial port, and 6 interrupt sources. Okay, this is about the features of different different MCS 51 family. Okay, next, the features of 8051 microcontroller. Okay, the first one, it is a 8-bit microcontroller. Okay, it is a what? An 8-bit microcontroller. 8-bit microcontroller means a what? It can transfer the data with 8 bit at a time. Okay, at a time 8 bit data. For example, 8 bits, 1 2 3 4 5 6 7 8 9 10. 10 numbers we need to transfer. So in order to transfer the 10 numbers at a time, we cannot transfer the 10 numbers. Okay, first it will take the 8 numbers and again 910 will comes in second. Okay, so like this it will convert, it will transfer the 8-bit data, and it is developed by Intel. Okay, it is developed by the Intel in 1980. Okay, it is developed by Intel in 1980, and it is high performance, means fabricated using CMOS technology. Okay, fabricated using CMOS technology, and it is also an IC, so it contains 40 pins, and all the 40 pins are dual in line package. Okay, means one pin is used for the multi-purpose. One pin is used for the multi-purpose. It consisting of 40 pins. Next, it consisting of 16 address lines. Okay, and 8 data lines. 16 address lines and 8 data lines, means address bus is of 16 bit, means 16 address lines, and data bus is of 8 bit, means 8 data lines. Next, ROM. Okay, 4 kilobytes. So total memory is divided into two types, ROM and RAM. So ROM is 4 kilobytes of internal ROM for storage of program memory, and for storage of data 128 bytes of internal RAM is used. Okay, so this is very important. The RAM size of 8051 is 128 bytes, and ROM size of 8051 is 4 kilobytes. Okay, next, 4 8-bit IO ports. 4 8-bit IO ports, P1, P2, P3, P4. Okay, so 4 ports we are having. Each port is consisting of 8 bits. Okay, each port consisting of 8 bits, and all the pins are 8 into 4 means 32. All the 32 pins are used for IO devices, for taking the input and giving the output. Okay, input output devices. How many pins we are using? Out of 40, 32 pins we are using for a input output ports. Next, two 16-bit timers. Okay, two 16-bit timers. What is the function of timers? What is mean by timers? I tell later. Okay, two 16-bit timers. One, serial interface communication. If suppose we want to interface any external devices to take the application with the controller, means we need to interface. So that interface can be done in two ways, serial and parallel. So here serial interface communication will be done. Here serial interface communication will be done. Next, 64K external code and data memory space. So here, what is the size of ROM? 4 kilobytes. Okay, what is the size of RAM? 128 bytes. If this memory size is not enough, okay, is not enough to store the any program or data, we need some separate or extra memory to be interfaced, means so up to 64K we can extend the memory. Okay, this ROM we can extend up to 64K by adding the external memory, and also this 128 bytes also we can extend up to 64 kilobytes of data. Okay, 64 kilobytes of external code and data memory space will be available. Next, 210-bit addressable locations. Okay, 210-bit addressable locations. Bit addressable locations means, see, 1 byte is equal to 8 bits. So if suppose we want to store, okay, for example, triple E we want to store. So triple E will occupy how many bits? Only 3 bits. But byte means what? 8 bits. So if we are writing triple E in that byte, then 3 bits. 3 bits only occupied. Now 8 minus 3, 5. 5 bits are empty. If suppose we want to store another number, then another name or everything, another will be stored in another byte. Means this 5 bits are will be remains like that only, empty only. That is called as byte addressable. Whereas bit addressable means bit by bit we can store. Triple E means 3 bits. Again 5 bits are left. So these 5 bits can be used for storage of another lines, another variables, another characters. So that is called as bit addressable. So like that, here 210 bit addressable locations we are having. In 8051 is having how many bit addressable locations? 210 bit addressable locations. Next, internal memory consisting of on-chip ROM and on-chip data RAM. Okay, so I said 4 kilobytes of ROM and 128 bytes of internal RAM. So this will be available in internally on chip. By controller means CPU along with all the peripherals on a IC. So RAM ROM will be fabricated on a internal. Next, 8051 implements a separate memory space for program, that is codes and data. Okay, by this is constructed based on the Harvard architecture. Harvard architecture means the what? Okay, memory for program separate memory and for storage of data separate memory. Okay, so 8051 implements a separate memory space for a program code and data. Next, operating frequency is 20 megahertz to 24 megahertz to 33 megahertz. Operating frequency is 24 megahertz to 33 megahertz. Next, it requires plus 5 volts regulated DC power supply. Okay, it requires plus 5 volts regulated DC power supply to operate. Next, it has 4 8-bit ports. So totally 32 IO lines, 4 8-bit ports. Okay, next, RAM, ROM, IO ports, one serial port, and timers are all on a chip. Okay, next, 6 interrupts. Okay, this one is having 8051 is having 6 interrupts. 2 are external and 2 are internal. One is reset, 3 are external, 2 are internal, and one is reset. Okay, so 6 interrupts. Next, low power ideal and power down modes means this one will be operated under two modes, power down mode and low ideal mode. Okay, power down mode and ideal mode. I'll tell later what is power down and what is ideal mode. So this is operated under two modes. Okay, low power ideal, or it is also called as ideal mode, and second one is power down modes. Next, full duplex UART asynchronous. Okay, this one also I will tell later. Full duplex UART is used. 8051 has 21 special function registers. Okay, 8051 is having 21 special function registers. Okay, processor is having how many registers? 14. But whereas here 8051 is having 21 special function registers. So all these are the what? The features of 8051. Okay, understand? Understand? Give response.
Yes, ma'am.
Yes, ma'am.
All these are the very important
Yes, ma'am.
features. Okay, next, block diagram. Okay, this is the block diagram of 8051. Block diagram of 8051. So this consisting of what? With the definition. What is the definition of the controller? CPU and all the peripheral devices. Oscillator, bus control, input output port, serial, RAM, ROM, timers, all are the peripherals only. All these are called peripherals, right? So, microcontroller means what? CPU along with all the peripherals on a single IC is called as microcontroller. So, this is the block diagram of microcontroller. Okay, cpu means what? Central processing unit. CPU means what? Central processing unit. So it is the heart, brain, anything you can assume. Okay, this is very important. This is heart of the microcontroller. Okay, This is heart of the microcontroller. And this one is consisting of what? Further, ALU and ALU, some temporary registers, and some control unit. Okay. CPU means what? ALU and control unit. ALU means what? As it name says, it performs the arithmetic and logic unit. Okay. Arithmetic and logic unit. And control signals. Okay. Control unit. Timing and control unit. So this timing and control unit performs the internal operation with the frequency of clock. Okay. This CPU consisting of clock generator. So this clock generator performs the internal operation with the frequency of clock signals. This oscillator will generate the clock signals. Okay, to data flow control. So it will control the data flow from the microcontroller. Okay, bus controller. Bus controller will control the internal bus. Okay, means if suppose CPU is there, we have given some task to the CPU. Okay, that will be stored temporarily, means the data will be moved to the RAM. Okay, if suppose that should be goes to the output, means we want to display, then the data will be moved to the IO ports. Then all the data flow will be controlled by bus control. Okay, and for flow of data control, the certain time will be considered. Okay, that time will be allocated by the this oscillator or clock unit which is inside the CPU. Okay, next 4 kilobytes of ROM. So ROM is used to store the program memory. Okay, used to store the program. RAM 128 bytes of RAM means for temporary storage of data. Okay, this is read only memory. This is random access memory. Here we cannot write. Okay, this is used for the operating system. If in order to work the microcontroller, we need to install some program, right? So that program will be stored by permanently stored by this ROM, read only memory. Whereas this random access memory means here we can read, we can write. If suddenly power will be off, okay, suddenly we are switching off the microcontroller means the data which is stored in the RAM will be erased. But whereas the data will be stored in the ROM will not be erased. Why? Because this is read only memory. We cannot erase. Whereas here we can erase. If suddenly we'll switch off the microcontroller, then data will be erased. Means the data will be stored temporarily. Okay. Timers. This one is having two timers. Okay, I'll tell later about the timers. This is for the communication between the external devices. Serial communication will be done. Okay, for transmission, RXD means receiving, transmission and receiving. Interrupt control. This one is having 6 interrupts. 8051 is having 6 interrupts. Okay, 3 external, 2 internal, 1 reset. So this is interrupt controller. Okay, this is about the block diagram of 8051, and here oscillator circuit is there. Oscillator circuit is also called as clock generator. Okay, oscillator circuit is also called as clock generator, which generates the clock pulses. Okay, this one will generate the clock pulses to perform the microcontroller operation. Okay, it generates the clock pulses to perform the microcontroller operation. Microcontroller operation means what? For reading. If any data we are giving to the controller through the input means controller should read the data. Okay, that is one operation. And if you want to display something on the output, controller has to display something on the output, then write operation will be done. Means clock generator will generate the clock pulses to perform the microcontroller operation, means read write operations. Okay, RAM is over. Okay, timers, two timers, it determines the time period. Okay, this is about the entire block diagram of 8051. Next, internal architecture. Okay, internal architecture. The 8051 requires an external oscillator circuit. Okay, here this one external. Okay, here internal is there, and also we want to connect the external oscillator circuit. The oscillator circuit usually runs around 12 megahertz. Okay, the oscillatory circuit usually runs around 12 megahertz. The crystal generator, that is nothing but a oscillator circuit, generates 12 m megapulses in 1 second. Okay, the pulse is used to synchronize the system operation in a controlled place. Okay, in a controlled place. Next, an 8051 machine cycle consisting of 12 crystal pulses. Okay, so this one will generate the 12 megapulses in 1 second. But one machine cycle consisting of how many crystal pulses? 12 crystal pulses. Clock cycle. Okay. Already I explained clock cycle in microprocessor. Okay. Used for synchronizing internal operation. It is used for synchronizing internal operation. Pins XTAL1 and XTAL2 have been used. Okay. See here. Here we are connecting the two pins XTAL1 and XTAL2. So with the help of these two pins, we are generating the pulses. Okay, we are generating the pulses which are used to synchronize the system operations in a controlled way. Okay, next, the length of the machine cycle depends on the frequency of the crystal oscillator circuit. Okay, crystal oscillator circuit. This is about the oscillator circuit. Next, this is the entire architecture of 8051. See here, these are the two crystal oscillators pins XTAL1 and XTAL2. These will generate the pulses. Okay, this one we are connecting external to the process controller. Okay, this is the entire architecture of 8051 microcontroller. Okay, entire architecture of 8051 microcontroller. First, see the entire architecture. Okay, so it consisting of both RAM and ROM, accumulator, some registers, A register, B register, temporary register, arithmetic and logic unit, program status word, timing and control signals, port 1, port 2, 0, 3, 4, 8-bit ports. Okay, these are the special functions which we are using. Stack pointer, program counter, RAM. Okay, and to access the ports, port latch and means port 0, port 2. All will be accessed with the help of the latches. Program counter, program adder register, data pointer, interrupts, IE, IP, timers, TCON, SCON, TMO, TCON. These all are the special function registers. So this is what the entire architecture of 8051. Okay. Next, internal. Okay, internal memory. So 8051 is having two types of memory. Okay, for program, for storage of code or program, it uses the separate memory, and also for storage of data it uses the separate memory. Okay, so the 8051 microcontroller memory is separated in program memory, that is ROM, and data memory, that is RAM. Both code and data may be internally. Okay, both code and data may be internal. However, both expand using external components. Okay, however, both expand using external components to a maximum of 64 kilobytes. If more than that we want to interface means the controller cannot accept. Okay, 64 kilobytes of memory only, up to this much memory only we can interface externally, both program and for memory. But more than that it won't accept. Program and data memory. Internal memory consists of on-chip ROM and on-chip data RAM. Both should be on a one chip. Okay. So again RAM is divides into a general purpose registers, bit addressable register, and some special function registers. And in the 8051 the registers and input output ports are memory mapped and accessible like any other memory location. Okay, next we'll discuss about the memory organization. This is about the memory. Okay, so 8051 microcontroller memory organization is divided into two types: ROM, RAM. ROM is for storage of program or code. RAM is used for storage of data. Okay, now first we will discuss about the program memory. Program memory. So in 8051 microcontroller, the code or instructions to be executed are stored in the program memory. Okay, the code or instructions to be executed are stored in the program memory. Okay, so this one is also called as what? ROM, ROM of the microcontroller. Okay, so how much size we are having this ROM? 8051 is having 4 kilobytes of internal ROM. Okay, 8051 is having how much ROM? 4 kilobytes of ROM. Okay, so this is the program memory. So here, this is the internal program memory. This is connected internally in the processor. Now if you want to extend, okay, if you want to extend or expand this memory, means we want to interface some more memory externally, means like this we can connect. And how we can access, how the controller can access this external memory means whenever the EA pin will be there. Okay, in 8051 EA pin will be there. Okay, whenever this EA pin will be goes to logic 1 plus 5 volts, means logic 1 plus 5 volts will be given, then you can microcontroller can access both internal program memory, both ROM, and as well as externally some memory we are attaching to expand the ROM. So both can be accessed whenever EA pin will goes to high. If EA pin will goes to low, then you cannot access internal ROM. Okay, you cannot access internal ROM. You will access external ROM only. Okay, this one only you can access whenever EA pin will be logic 0. If EA pin will be logic high, then you can access both internal ROM and external memory for program storage only. Understand? This is about the program. And what is the maximum expandable memory? 64K. Up to 64K we can extend ROM, means we can connect externally to this microcontroller. If this ROM is filled, we want some more memory for the program, for the storage of the program, then up to 64 kilobytes of memory we can extend, we can connect externally, we can interface externally, not more than that. So in order to select the both the memories, external ROM and internal ROM, EA should be high. If EA should be low means only you can access, microcontroller can access program memory. Okay, external RAM only controller can access, not this internal ROM. Next, data memory. Data memory means RAM, internal memory RAM. Okay, so this is assigned in it. So address is assigned in hexadecimal always in every IC. So 8051 is allocating 128 bytes of internal RAM. Okay, what is the size of the internal RAM of 8051? RAM size 128 bytes. Okay, 128 bytes. And locations, if we are converting these 128 bytes into hexa, then the address size is of 00 to 7F. Okay, the address size is of how much? 00 to 7F. Okay, these addresses are assigned. Now this is the total internal RAM. Okay, this is what a total internal RAM size is 00 to 7F, means 128 bytes. Okay, 128 bytes this one is having. The size of the internal RAM memory is how much? RAM memory 128 bytes. Okay, 128 bytes, and the range is of starting is 00 to 7F. Okay, 7F. And now the internal RAM is organized or divides into a three types. Okay, internal RAM is organized as divides into a three types. So this 8051 is having 128 bytes of RAM. This is divides into a three parts. Okay, first part means first 00 to 1F means first 32 bytes. Okay, total size is 128 bytes. Okay, total size is 128 bytes, and the locations are up to 7F. So here first 32. Okay, first 32 bytes. Okay, first 32 bytes of internal RAM is allocated for 4 register banks. Okay, 4 register banks, and each register bank is having 8 bits. Okay, each register bank is having how many bits? 8 bits. So these register banks are given as names: bank 0, bank 1, bank 2, bank 3. Okay, so total 128 bytes of internal RAM is divided into a three parts. First part is first 32 bytes are allocated for 4 register banks, means these register banks are used for temporary storage of data. These register banks are used for temporary storage of data. So how many banks we are having? 4 banks: bank 0, bank 1, bank 2, bank 3. All these banks individually consisting of 8 bits. Sorry, 8 bytes. Okay, 0 to first bank 0 is having 00 to 07, bank 1 is 08 to 0F, bank 2 is 10 to 17, bank 3 is 18 to 1F. So 32 bytes are over. And now whenever we will switch off the entire controller, then the data will be moved into the bank 0. Okay, now the question is what? If suppose something we are writing in the controller, then the data will be moved into where? Whether bank 0 will take the data, or bank 1, bank 2, bank 3. How we can decide? Means whenever you will switch off the entire microcontroller, bank 0, the data will be moved into the bank 0. Okay, now whenever you will switch on, the data will be moved into these three banks. Again, these three banks, which bank we need to prefer means that will be based on the two registers of program status words. Okay, two registers of program status word, RS1 and RS2. Two registers are present in the program status word. So if the two registers are 00 means bank 0, 01 means bank 1, 10 means bank 2, 11 means bank 3. Who will decide the data will be moved into the which bank? two registers RS1 and RS2, third and fourth pin of program status word. Okay, while discussing about the program status word, I'll tell about those registers. Okay, so the two registers or two bits of the program status word will decide the which bank is used for the storage of data. RS1 and RS2. Okay, next 32 bits is 32 bytes is over. Next another 16 bytes. Okay, another 16 bytes of memory is allocated for the bit addressable. Okay, bit addressable memory. Okay, first 32 is for what? Banks, register banks. Each bank will consisting of 8 bytes. Okay, now another 16 bytes, that is 20 to 2f. F means 16, right? So 20 to 2f. So 16 bytes of data or 16 bytes of memory is allocated for bit addressable memory. Okay, bit addressable memory. Okay, so the address is range is 220 to 2f. So here bit addressable means what? This is byte addressable. These registers are byte addressable. So just now I have given the one example that I want to store the triple E. So triple E means 3 bits. Okay. So if that triple E we want to store in this bank means 1 byte will be occupied. But the size of that word will be how much? 3 bits only. Okay. Remaining 5 bits will be wasted. But whereas in bit addresser, okay, bit by bit we can address. Okay, bit by bit we can address like this. Okay, so 7 if triple E is there means 0 1 2 3, these 3 bits will be occupied and remaining 3 4 5 6 7 will be for other, to store the other information, other data. Whereas in byte addressable, if triple E we are storing here 0 1 2 3, then entire line will be occupied, entire byte will be occupied, even though some space will be empty. Okay, understand? Byte addressable means entire byte will be occupied, whereas bit addressable means bit by bit we can save. Okay, bit addressable. Next, remaining 80 bytes. Okay, first 32 is allocated for the register banks and next 16 bytes are allocated for the bit addressable memory and remaining 80 bytes are reserved for some general purpose registers. Okay, some general purpose area, that is 30 to 7f. First range is 00 to 1f, next 20 to 2f, next 30 to 7f. So total internal memory of 8051 RAM is organized into a 3 parts. This is very important. Organized into a 3 parts. Okay. First part, that is 32 bytes of memory allocated for what? Banks, register banks. Next 16 bytes are allocated for bit addressable memory. Next remaining 80 bytes are allocated for general purpose. So this is the organization of total internal RAM 8051. Total RAM size is how much? 128 bytes. Okay, this is okay. First 32 bytes, 3 banks. So R0, R1, R2. First bank, bank 0, bank 2, bank 1, bank 2, bank 3. Further bank 0 consisting of 8 registers. 8 registers of 8 bit size or 1 byte. Okay, now which bank will be selected? Who will decide? RS1 and RS0. Okay, RS1 and RS0 pins of program status word, third bit and fourth bit will decide the data will be moved into which bank. RS1, RS000 means bank 0. The data will be moved into the bank 0. 01 means bank 1. 10 means bank 2. 11 means bank 3. If both will be 00 means that will be happened when the system is switched off. The system is switched off, then the total data will be moved into the bank 0. Okay, and this is called as bit addressable. Bit by bit we are representing. Understand? Bit addressable, and this is bank register banks, and this one is general purpose bit addressable banks. Understand? Memory organization of 8051 RAM. Understand or any doubts?
Yes, ma'am.
Yes, ma'am.
Yes,
Okay, very very important. Internal RAM is organized into a three types. That first 32 bytes of memory is allocated for 4 register banks. 4 register banks further divides into a 8 registers. Okay, and next 16 bytes of memory is allocated for the bit addressable memory, and remaining 80 bytes of memory is allocated for the general purpose. Okay, this is about the memory organization of 8051. Internal memory organization RAM of 8051. Okay, this is also same thing. Okay, register bank 0 1 2 3. Okay, and further bank 0 consisting 8 registers, bank 1 consisting 8, bank 2 consisting 8, bank 3 also 8. Next, special function registers. So along with this register banks, this one also have the 21 special function registers. How many registers? 21. Okay, so here these special function registers includes these 9 and also some ports, port numbers, port A, port B, port C, also some interrupts. Okay, like that 8051 is having how many special function registers? 21 special function register. ACC means accumulator. Okay, in microprocessor accumulator will be represented by A letter, but whereas here ACC. Okay, B register, program status word, PSW, SP stack pointer, DPTR data pointer, IP interrupt pointer, program mode, PCON, T mode, TCON. These two are the timers. Okay. Next, PSW register. Okay, this is the program status word. Okay, program status word. So program status word is 8-bit size. What is the size of the program status word? 8-bit size. Okay, 1 D0 1 2 3 4 5 6 7. Okay, so first we will discuss about this program status word. This is a special function register, and based on the pins of the special function register PSW, we will decide which bank we can use to store the data. Okay, so already I explained third and fourth pin of PSW. Okay, third and fourth pin of PSW will decide the bank. Register bank, both are 0 means bank 0 will be selected, means the data will be moved into the addresses 00 to 07. It can occupy any address in 00 to 07. If RS1 is 0, RS0 is 1 means bank 0 will be occupied. Means in order to store the data, controller can use 08 to 0F address. Okay, Between these locations only it can use. Similarly, 10 means bank 2. 11 means bank 3. Next, first bit P. P means parity. It will give the parity. Means what? If the result is odds or evens. Okay. If the result is odds, means it will goes to 1. Even number means it will goes to 0. Same function as I already explained in the processor. Parity bit. Huh? This is not defined, undefined. Next, OV, overflow flag, means if the result is overflow. If 8-bit plus 8-bit, we will get the 8-bit data only. If suppose 9-bit data we are getting, means what? One bit is overflow. Then at that time, this OV will goes to 1. Okay. Next, F0. This is available for the general purpose. Okay. AC is auxiliary carry flag. Auxiliary carry flag means in the result from nibble to nibble, if we will get the any carry, nibble means 4 bits. 1 byte means 8 bits. So again 8 bits consisting of 2 nibbles means 4 bits, 1 nibble. So 2 nibbles. If nibble to nibble means 4th bit to 5th bit, while doing any operation, if we are getting any carry, then auxiliary carry flag will be enabled. Okay, means AC will be goes to 1. CY. If we are getting any carry in the result means we will get the carry flag. This is about the program status word. Okay, what is this? Program status word. Next, about the special function registers. So 8051 is having how many special function registers? 20 special function registers. Okay. So the last one, 82 FFH, I said. Okay. Means some memory in the 8051 internal RAM, some memory is allocated for the general purpose. Okay. So that will be occupied by the 21 special function registers. So all the here in special function register, the size of all these special function registers are not same. Like in the processor, all the 14 registers will have the same size, that is 16 bits. Okay, 8086 is having 14 16-bit registers. But whereas here, these registers, some of them will have 16-bit size and some of them will have 8-bit size. Okay, or some of them will have bit addressable also. Okay, so some special function registers are both bit addressable and byte addressable. And also some will have length of 16-bit and some will have length of 8-bit. Okay, so PSW is one of the special function register. Next register is B register. Accumulator is also one special function register. Next register is B register. So this B register or accumulator B, it is also called as accumulator B, is used along with the accumulator for multiply and divide operations. Okay. A is used for the arithmetic and logical operations, addition and subtraction, and B is used for multiply and divide operations along with the accumulator. Okay. For example, MULAB multiplies 8-bit assigned value in A and B. Whereas in microprocessor, how we gave MULA comma B, but here we need to give MULAB. Similarly, division means div AB. No comma, no space between A and B. And B register is bit addressable. Bit addressable means bit by bit we can store. This is program status word. Already I explained stack pointer. Okay, stack pointer is an 8-bit register. Okay, stack pointer is an 8-bit register. Address is at 81H. Means starting address of stack pointer is 81H. It contains the address of the data item currently on top of the stack, same like a processor. Okay, pushing pop. With push and pop, we can move the data into the stack pointer. Okay, same function. Okay, stack operations including pushing data on the stack and popping data of the stack. Pushing means inserting the data. Popping means taking the data from the stack. Pushing means increments the data. Popping means decrements the data. Next, data pointer. So data pointer is a 16-bit register. Stack pointer is 8-bit. Program status word 8-bit. B register also 8-bit. But here data pointer is 16-bit register. Okay, and is used to access the external data or code. External data or code. While writing the program, if we want to store the any external data, 28 we want to write, and the 28 we want to store in the external data, then we should use compulsory dptr in place of a. Okay, the data pointer is used in operations regarding external RAM and some instructions involving the code memory. See, for example, here also given move x at dptra means what is the data present in the 55H that will be moved into the dptr. Dptr means directly this 55H is moved into the external memory. Okay, so whenever we are using at dptr, at that time in order to move, compulsory we should use move x, not to move. Okay, to store the data in the externally memory that is connected external to the controller. Okay, to store the data in external memory we should use at dptr, or through the dptr register only we can store the data in the external memory. Next, IO ports, input output ports. Okay, input output ports. So 8051 is having all the input output ports are special function registers only. Input output ports are having 4 ports. 8051 is having 4 ports of each of 8 bits. Okay, P0, P1, P2, P3, 4 ports. Each port is having 8 pins. So totally 32 pins are used as a input and output. 32 pins we can use it as for input purpose and also for output purpose also. Okay, so this is the pin diagram of 8051. Okay, this is a pin diagram of 8051. See, it is a 40 pin dual inline package. Okay, it is a 40 pin dual inline package. So totally 40 pins. So here in the 40 pin, out of 40, 32 pins are set for a port to 0, port to 1, port to 3, port 0. Okay, AD0 to AD7, multiplexed AD, address and data lines. Okay, port to 1, P1 to P1.0 to P1.7, port to 2, P2.0 to P2.7, address lines. Okay, and P3, P3.0 to P3.7. See, first port is of all address and data. 8051 is having 16 address lines and 8 data lines. So, port 0, P0 consisting of multiplexed AD lines, address and data lines, 8. Port 2 consisting of only 8 address lines, A8 to A15. Okay, and these are simple inputs, and these will port 3 will have the multi-purpose. Okay, First, we will discuss one by one. VCC is provides a plus 5 volts regulated power supply. Okay. GND means ground. And XTAL1 and XTAL2 are the two inputs for the crystal oscillators. Okay. RD means read. WR bar. This is bar. Minus means bar. Means these two will be enabled for the logic 0. Okay. RD means RD bar. If pin 3.7 goes to 0 means read operation. Process controller will read the data. Okay. If controller wants to write the data means this P 3.6 should go 0. Okay. And INT 0, INT 1 are the two interrupts. And RXD, TXD are the used for the receiving data and transmitting data. Okay. Transmitting and receiving data. These two are used in serial communication. RST means reset. RST means reset. EA means what? Whenever EA is, this EA bar is goes to 1 means 8051 can access both internal ROM, ROM, and if suppose any external ROM, external memory we are connecting to use as a ROM means that can also be accessed. If this EA is goes to 0 means we cannot access internal ROM, ROM. ALE, address latch enable. In order to enable these address lines, first this ALE should goes to 1. Okay. One by one we'll discuss. Port 0. Port 0 is a 8-bit directional I/O port. Port 0 pins can be used as a high impedance inputs, and these are multiplexed lower order addressed and data bus. Okay. We are using pin numbers from 32 to 39 for port 0. Port 1 also 8-bit bidirectional. Means we can take input, we can give output. So 8-bit bidirectional. Port 1 have no dual functions. Okay, no dual function. Port 1 is having no dual function, all single purpose only. Okay, used as an output when the pin latches are programmed to 0. When all the pins are goes to 0 means these pins are used as a output. It goes to 1 means logic 1 means input. Okay, always remember 1 means input, 0 means output in all the ports. Here also. Okay, 0. If all the port pins are goes to 0 means logic 0 means all are used as a output lines. If those are goes to 1 means all are used as a input lines. 4 to 2. These are also 8-bit bidirectional I/O ports. Okay, same function. Port to 3. So here also port 3 is used for multi-purpose. So first these are used as a 8 bidirectional I/O ports. If all these bits are 0 means output lines used as output lines, and all these are goes to 1 means input lines. Okay, and RxD, TxD I already said for serial communication. RxD means receiving, means input port. TxD means transmitting data from controller to other devices, so output port. Okay, INT1, INT0 are the external interrupts. These are the two timer interrupts, T0, T1, WR for writing, enabling writing, reading, RD means. This is the basic circuit of 8051. Means we want to interface anything to the controller means the diagram should be connected like this. These two are the crystal oscillators, ground, supply, port 0, port 2, port 1, port 3. Okay. Any doubts till this?
No, ma'am.
No, ma'am.